Today we'll be starting the Net Primary Productivity Lab using the Pasco Optical Dissolved Oxygen Sensor. Primary productivity is the synthesis of organic compounds from carbon found in the water and in the air. Today we'll be using the photosynthetic organisms chlorella algae to do this experiment. To get started, we need to take the initial dissolved oxygen reading of the algae, and then we're going to take the algae and place them in 5 different bottles, which will be exposed to different amounts of light for 24 hours. I've pre-configured a SparkView file to collect our initial data point. The sensor in this case has also been calibrated in advance. We'll begin collecting data and wait for the measurement to stabilize before recording the initial value. Now that our measurements stabilize, I'll stop recording and record the initial measurement in our data table. All right. Now we will fill the primary productivity bottles. It's important when filling each of the bottles to cap the bottle fully submerged to make sure there are no air pockets. I'll dry the bottle off and then place it back in the appropriate chamber. I'm going to repeat this step for each of the remaining 4 bottles. Now that I have finished filling each of the bottles, I'll place the cover on it, which allows different amounts of light through to each bottle. The 0% solution will be used to calculate the amount of cellular respiration that occurs in the next 24 hours. The 100% through 25% solutions will allow us to see how primary productivity varies as a function of the amount of light that is allowed through. I will now place the bottles underneath a fluorescent light and allow the reaction to progress for 24 hours. Welcome back to Primary Productivity Day 2. Today we're going to continue our investigation by taking the optical dissolved oxygen measurement after our bottles have been exposed to light for 24 hours. I'll begin by carefully opening up our bottles. We want to make sure not to shake the bottles or introduce any oxygen from the environment. So I'm going to start with the 100% bottle. And once again, our oxygen sensor has been pre-calibrated for use. Begin collecting data. And I'm going to place the sensor in the bottle just long enough until the measurement has stabilized. All right. I will proceed down the line to the 75% bottle. And again, once we have a stable measurement, I'll press check to proceed. And on to the 50% bottle. This data is looking really good so far. All right, and on to the 25% bottle. And the final one will be the dark bottle. This bottle was completely covered and received no light. It's taking just a little bit longer to stabilize here. The oxygen concentration looks like it's below 1 milligram per liter. All right, that looks pretty good. So now I'm going to go ahead and hit stop. And now we'll proceed on to the analysis, which just involves a few simple calculations to get the gross and primary productivity as well as the respiration rate. So in the first part of the analysis here, we'll be calculating the gross productivity, which is the light bottle minus the dark final dissolved oxygen concentration. And then after that, the net productivity, which is the light bottle again of the correct concentration, minus the initial dissolved oxygen, which we measured on day 1. We could use a calculation under these values. I'm going to go ahead and do it manually, or you can have your students record their data in their lab notebook. All right, and now I'll go ahead and calculate the net productivity. All right. Now we'll proceed to the second step of analysis where we'll calculate the respiration rate, and we'll be able to see how the percentage of light that was getting to each bottle affected the net primary productivity. As you can see in the graph here, as more light was available to the chlorella, the primary productivity went up considerably. In fact, until we got to around 50% of the light getting through to the bottle, we were seeing more respiration than productivity taking place. So finally, we'll calculate our respiration rate, which is the initial dissolved oxygen minus the dissolved oxygen consumed in the dark bottle. So we had a respiration rate of about 7.76 milligrams per liter per day. And that's based on just the small amount of algae suspended in this bottle right here. All right, that concludes the primary productivity lab. Thank you for watching.